Okay, this is the end, I believe, of Chapter 2, Section 2. This is Part 2 continued. You'll notice here that I've got some little penguins on my coordinate plane. So we can, get used to, again, positive slope, negative slope, zero slope, and undefined slope. So I see here this penguin. From left to right, this line is rising. So both in the x and the y direction, we are moving positive. So this is a positive slope. I'm going to the right on my x and I'm coming up on my y. It's both in the positive direction. So this is a positive slope. If you were thinking going backwards, well, this would be going down and to the left, so that's negative over negative. Or from the left to the right, that would be up in the positive direction and over in the positive direction, up and over, up and over. So this is my positive slope. This one here has absolutely no slope. And if you recall from the last video, we did talk about the value for none is 0. This is my horizontal line. This is my 0 slope. Here's the one that's undefined, because we can't say it has a slope, yet it's like a cliff. You just drop down. Yeek! That's what this penguin is saying. Like, this is an undefined slope. And the reason it's undefined, and I did speak about this in the last video, is because you really have rise or fall, okay? You have rise, but you have no run. So this is like, rise up or down over no run. And so this is rise either positive or negative over 0, and that's undefined. And then here, if I read like in my book from left to right, this line is falling, and so we say this has a negative slope. The y values would be decreasing as the x values are increasing. So this should all be a review for you on slope. All right, this example here, it says graph each line, and we are going to graph each line on the same coordinate plane. Now, when we do that, you've got to label the lines with the lines equation. All right, so if I look at this one, this is a y equals 4. If I thought of this as a y equals mx plus b, this would be a line with a 0 slope, right? 0 times x. And then my b is 4. And so really everywhere on this line, the y value is going to be 4. It doesn't matter what the x value is. Everywhere on the line, the y value is going to be 4. This is my horizontal line. Okay, and then I'm going to take a straight edge. And I'm going to connect those points. And I'm going to label this as y is 4. Because everywhere on the line, y is 4. Now, in a similar fashion, letter B right next to it, x is negative 2. So if x is negative 2, in fact, everywhere on the line, x is going to be negative 2. And so when that happens, I get these points that are going to line up, and this is my vertical line. Okay, so an equation of a line, x is negative 2. That's your vertical line with an undefined slope. Okay, I'm going to move my paper up just so you can see my graph better. So again, x is 2, goes through the x-axis at, or negative 2 rather, goes through the x-axis at negative 2. And so I'm going to draw my line. I like to use different colors. Remember that you should always label the line's equation right on the line if you are graphing more than one line on the same coordinate plane. It's customary to do that. Okay, let's look at letter C. Bring the paper back down. I'm graphing a y equals mx plus b. I know I've got to plot the y-intercept, right? My m slope here is 3, or 3 over 1. And my y-intercept is the ordered pair 0, -2. Okay, so I'm going to go to where x is 0 and y is -2, and I'm going to put a dot. And I'm going to rise 3, 1, 2, 3, and run 1. Again, rise 1, 2, 3, and run 1. 1, 2, 3, and run 1. And I can go backwards. I can go downward 3, 1, 2, 3, and to the left 1. Negative over negative is still a positive slope. And that's probably enough points. So I'm going to bring this up here so you can see, right, from here to here I went down 3 and left 1. And now I'm going to draw my line that connects these points. And I'm going to label that line with its equation, y equals 3x subtract 2. Now I've got one last line to graph. Now, you could be slick and use one of those things that we did, graph it by finding intercepts. Okay, let x be 0, solve for y, let y be 0, solve for x. You could do that. You know, if I let x equals 0, right? If I let x equals 0, then I get 5y equals -10, or y equals -2. And so my ordered pair is 0, -2. And then I can let y be 0 and solve for x. Right? All I have to do is imagine that this isn't there, right? -2x plus 5 times 0 is -2x. And when I divide both sides by -2, I get, what, +5. So x is 5, and my ordered pair then is 5, 0. And now I can plot these two ordered pairs. X is 0, y is -2. Well, that's this point right here. This one. Sorry. This point right here. Yes? So I've got up here 0, -2. And now I'm going to plot 5, 0. X is 5, y is 0. And then I could connect those 2 points with a nice straight edge. And that would be the graph of -2x plus 5y equals -10. You could solve that equation, -2x plus 5y equals 10. You could take the 2x over, so I've got 5y equals +2x minus 10. And then divide by 5, y equals 2 divided by 5 times x minus 2. Here the m is 2/5, and my y-intercept is the ordered pair x is 0, y is -2. And I can check it. So I'm going to say, all right, the y-intercept is 0, -2. Yup, that works. And my slope is rise 2, run 5. 1, 2, 1, 2, 3, 4, 5. So there it is. It works either way. So again, if you see something in standard form, it's sometimes easy to just let x be 0, solve for y, let y be 0, solve for x, get those intercepts, and then graph the line. Sometimes, though, you end up with fractions, and students like to stay away from fractions. That's totally up to you which method you try. So, what are you going to know? You got to recognize that a y equals is a horizontal line, and x equals is a vertical line. Horizontal line has 0 slope. Vertical line has undefined slope. This is a straight on y equals mx plus b, not too difficult to graph. And then this, you could either graph by finding intercepts, or you can convert this into y equals and then graph it like we did with example C. So if you have any questions, post a comment or ask me in class when you see me so that I can help you. All right, on to side 2. This says write the equation of the line that's parallel and perpendicular to the given equation going through the given point. Folks, when you see parallel and or perpendicular, you should be thinking slope. Parallels have what kind of slopes? If you said the same, you're correct. Perpendicular lines have what kind of slope? If you said opposite reciprocals, you would be correct. I'm going to abbreviate. OPP-RECIP is opposite reciprocal. All right, so when you hear about parallel and perpendicular lines, you should be thinking slope. And they're giving me a point. We will be using point slope form. We've done this in a previous lesson. So if I'm writing a line that's parallel, you should be saying to yourself, this is the same slope. So if the slope of the given line is negative 1/3, then the slope of the parallel line is also negative 1/3. I like to give a little subscript of parallel. Those of you that had geometry, okay, that's the symbol for parallel. Same slope. M of the parallel line, what I'm going to be using is negative 1/3. Put a box around it so you know you're going to use that to build your equation. Here's my point. So I have to be in point slope form. Y subtract y from the point equals m times x subtract x from the point. Recall this. Y subtract, I'm going to put a parenthesis placeholder. I know my slope is negative 1/3. X subtract, again, I'm going to put a parenthesis placeholder. Here's my x. X is 6 and y is negative 1. You got to put them in the proper position. Okay. Y subtract subtract. Well, that's the opposite of a negative, which is positive. This is y plus 1 equals negative 1/3 times the quantity x minus 6. Now, do I want to leave it like that, or what are my directions? Write the equation of the line parallel and perpendicular to the given equation going through the given point. They did not tell me. So I'm going to put a box around this and just say this is point slope, P dot S. Understand my abbreviation? If you don't, please ask. I'm now going to convert this to slope intercept. I'm going all three forms actually on this. All right, I have to distribute. So I get a y plus 1 equals negative 1/3 x. I'm distributing. 1/3 of 6 is 2. Negative times negative is positive. And now all I have to do is bring the 1 over. So y equals negative 1/3 x, right? This is variable term. I'm going to combine that with that. Plus 1. Put a box around it. I'm going to say this is my SI. SI for slope intercept form. Now I'm going to take this one step further and put it in standard form. Remember, I need the x and the y on the same side. So this becomes positive 1/3 x plus y equals 1. Remember, we can't have fractions in standard form. So I'm going to take this whole equation and get rid of that 3 in the denominator. The only way to get rid of it is to multiply by 3. And when I do that, 3 times 1/3 is 1. I get 1x. 3 times y is 3y. 3 times 1 is 3. This is my standard form, ST, or you could just say standard. Okay, so we've done all three forms. What's the new stuff? Well, the only thing really that's new is to determine which slope you're going to use. And then know that you're given a point and you have the slope, so you've got to use point slope. And then you've got to read the directions to see what form your answer should be in. Whether it's point slope form, that would be this form. Slope intercept, right? That's the slope, that's the y-intercept. Or standard form where you have your ax plus by equals c. Let's do the same equation, this time for perpendicular case. All right. What do we know about perpendicular lines? Well, slopes are not the same. They are opposite reciprocals. which means my slope and upside down capital T is perpendicular symbol. So if the given slope is negative 1/3, I look over here, I'm using the same equation. If the given slope is negative 1/3, right here, then I have to flip it and change the sign. So the opposite of negative is positive, and the reciprocal of 1/3 is 3. So the slope I'm going to use for this problem is 3. I'm going to do the same exact thing I did over here. Y subtract y from the point equals m the slope 3 this time, x subtract x from the point. I'm still using this point. These equations that I'm writing are equations of the same line that are perpendicular to this line now. So I'm still putting negative 1 here. I'm still putting a 6 here. Y plus 1 equals 3 times the quantity x minus 6. The only thing that has changed from this to this is the slope, because this line is parallel, this one's perpendicular. This we're going to say PS because that's point slope. Now I'm going to distribute and move the 1 to put it in slope-intercept form. So I get y plus 1 equals 3 times x is 3x, 6 times 3 is 18, it's negative. Take the 1 over, y equals 3x, subtract 19. Here is my slope-intercept. Okay, if you don't like using the initials, then write the whole thing out. Now I need to put it in standard form. That means the x and the y have to be on the same side. So I'm going to take the 3x over. It's positive on the right, would be negative on the left. I end up with this, negative 3x plus y equals negative 19. Now, one thing you do have to remember is I can't have a leading negative in my standard form. Not only do I have to make sure that these are all integers, but I have to make sure that a is a positive integer. And that's okay, because all I have to do then is multiply by a negative 1. Right? And when we multiply the whole equation by negative 1, you have to distribute. So I get a positive 3x subtract a y equals 19. And this is my standard form. Okay, so what do you have to remember? Well, you have to look. Am I parallel or perpendicular? And it's all about the slopes. Parallel, same slope, perpendicular, opposite reciprocal slope. So you want to identify the slopes that you're going to be using when you're writing your equations. You're given a point, you know the slope, and so you go into point slope form. Look to see if the directions say what form to give your final answer in. We, just for the purposes of the note sheet, are giving our answer in all 3 forms so that you have it there when you're working on your homework. All right, so why don't you pause the video and see if you could do example B on your own. And then you can play through the video and see if you got it correct. Okay, I made a little pause in the video. Hopefully you did pause the video and work this through. Parallel lines have the same slope, so the slope, I'm looking here, y equals 2/3 x subtract 7. I know the slope is 2/3. Okay, I know parallel lines have the same slope, so I know the slope here is going to be positive 2/3. Over here on the perpendicular side, I'm going to say the slope of the perpendicular line is not positive but negative, and not 2/3 but 3/2. So this is me just identifying my slopes for both cases right in the beginning. My ordered pair is -3, -2. I've got a point and I've got slopes. So I'm going to write out y subtract y from the point equals m 2/3. Multiply with the quantity x subtract x from the point. Over here I'm going to set it up, y subtract y from the point equals -3/2 this time, x subtract x from the point. Now the x is -3, so I'm going to fill them both in. The y is -2, so I'm going to fill them both in. I'm going to work with one at a time, but I just wanted to get my setup so I can, organize myself. Now I'm just going to work over here on this side. This becomes y plus 2 equals 2/3. Now remember, we never distribute the slope in for point slope form. This is x plus 3. I am finished with point slope form. Distribute and get the y by itself for your slope intercept form. Y plus 2 equals 2/3 x. Well, look at here. This is 2/3 times 3 or times 3 over 1. The 3's are going to divide out. This is plus 2. And then when I take this to the other side, guess what happens to the 2's? They go away. So what? The y-intercept is 0. Okay, so here's my y equals 2/3 x. That is my slope intercept, right? Because I could write a plus 0, so my y-intercept is 0. Now I'm going to take the x and the y over to the same side. So I've got a -2/3 x plus y equals 0. Remember, I never want a, or the leader, to be negative, and I can't have this be a fraction. Now, I'm not going to multiply by the reciprocal. I'm going to multiply by what's in the denominator to get rid of the 3. Okay? Because I want the 3's to divide out, leaving me with -2. Oh, yeah, I can't have that negative, so I'm going to distribute a -3 inside. So negative times negative is positive. The 3's are going to divide out. This becomes 2x. Subtract 3y equals 0. Folks, this is my standard form. Not too bad, I don't think. All right, over to the next one. I already did the setup in the beginning of the problem, so I didn't confuse my slopes. Everything else is the same. This becomes y plus 2 equals -3 over 2 times the quantity x plus 3. This is point slope, right? I do not distribute the slope through. Now I'm going to distribute the slope through and take the 2 over. Why? Because I have to have it solved for y for this to be in slope-intercept form. All right, 3 times 3 is 9. This is going to be 9 divided by 2, so this is -9/2. I'm not finished. Isn't 2 really 4/2? Okay, so I'm going to think of this as subtract 4/2, right? Because that's going to be 0. So y equals, and if I subtract 4/2 here, I'm going to subtract 4/2 here. You want to think ahead when you have fractions. Get a common denominator right away. -3 over 2 times x. Now, -9/2 subtract 4/2 is -13/2. I know, weird fractions. All right, this is my slope-intercept form because I see the slope and I see the y-intercept. 13/2. Don't be afraid of it. It's just 6.5. But, folks, I do not want decimals, okay? You have to give me fractions. Hopefully you're all listening to the videos. I know some of us are missing some important key concepts that you're not picking up from the video. There's nothing saying that you can't write more on your note sheet than what I'm writing. So that would probably be a good thing for you to do. Maybe stop the video, rewind it, and say, wait a minute, what did she just say there? All right, last type. Standard form. Take the x to the other side. That's going to become +3/2 x plus y equals -13/2. I'm not finished yet because I have an icky fraction there. So I want to get rid of the 2 in the denominator. So multiply this whole thing by 2, or 2 over 1. Yes? Now, if this would be different, if this would be like a 3, then I'd have to multiply by 6. Right? Think about it. I wouldn't be able to get rid of a 2 and a 3 without multiplying it by 6. So be cognizant of that in your homework. 2's are going to divide out. This is 3x. This is 2y. And these 2's will divide out. What am I left with? -13. This is my standard form. So, if you have questions, something didn't make sense after you have rewound the video, post a comment on the discussion post or ask a question in class. Now, this worksheet 2.2 is your, I believe, Thursday's homework. Okay, and then the review for the quiz is Friday's homework. All right, because I'm not in class those 2 days. So keep that in mind. This is Thursday. I will, from wherever I am, set myself an alarm or something to post the answers for worksheet 2-2. If I don't get to it, then it's okay because we can check it on Monday. I will be back for Monday. And then on Friday, you're going to work on the review for the quiz and submit that. The earlier you submit the review on Friday, the earlier I could post the answer key for you. I can't post it until everyone submits. So if that's Monday, then that's Monday. But, you know, take it for what it's worth. I can't submit the answers until all of the assignments have been submitted. Okay, one more time. What do we know about parallel and perpendicular? Parallel lines have the same slope, so you copy the same slope. Perpendicular lines have slopes that are opposite reciprocals. So the opposite of positive is negative. The flip of 2/3 is 3/2. And then you just set up and put it in point slope form. You have to read the directions to make sure you know if you're putting it in or keeping it in point slope form, slope intercept form, or standard form. So if you have any questions, please ask. Have a great weekend.